Hey there, I'm a water molecule. I'm made of one oxygen atom and two hydrogen atoms. Pretty cool, huh? Most of the electrons hang out around the oxygen end of this molecule. That leaves the hydrogens positive. Molecules, like water, that have this unequal charge distribution are known as polar molecules. Because of these unique electrical charges, polar molecules are attracted to one another, like this. Opposites attract. With molecules, more than two can play this game. This weak attraction between two polar molecules is known as a hydrogen bond. Hydrogen bonding between polar water molecules gives water its amazing property known as surface tension, allowing things like drops to form. Without surface tension, hey, water striders wouldn't be able to walk on top of the water. All this hydrogen bonding makes water pretty sticky, doesn't it? This is called cohesion. If water didn't show properties of cohesion, you wouldn't have raindrops. You wouldn't have any kind of drops. A lot of creatures depend on water drops in order to drink. For a really tiny little molecule, water has an incredibly high boiling point, all because of that hydrogen bonding. As the water heats up, the molecules start jiggling faster and faster, but the hydrogen bonding still holds them together like glue. Eventually, when the water reaches about 100 degrees, the energy is so great that the molecules break apart from their hydrogen bond and they evaporate into the atmosphere. Okay, on a practical sense, this means water has an incredibly high heat capacity. In other words, it takes a lot of energy to raise the temperature of water 1 degree. We'll talk about that later. Because water is polar, water molecules can form hydrogen bonds to other materials that also show different degrees of polarity, such as a dog's tongue. Check this video out. Charged areas on the water molecule adhere to oppositely charged areas on the tongue. This is known as adhesion. And without adhesion, the dog wouldn't be able to drink. In this video, the adhesion of water molecules to the grains of sand in this column allow the water molecules to move upwards against the force of gravity. This is known as capillary action. Capillary action, using both the properties of cohesion and adhesion, enable groundwater to reach the surface so plants can absorb water through their roots. Without capillary action, plants would probably die. Here I am in the Australian rainforest, and I picked out this nice fig to climb today. And I've thrown my rope over the lowest limb, which is probably about 30 feet up. Here's a little view of the creek gully. Got myself all hooked up here. D53 climber's knot. I think I'm good to go up. Okay, made it to the top. And just checking out the view. And here's the view from the top of the rainforest fig. And capillary action is what makes it possible for these trees to get water all the way to their leaves. Well, I hope you enjoyed learning about properties of water. It's pretty amazing stuff. But before we get into any more details, let's take a look at some of my friends from Australia.